Okay, now we're going to take those log properties and use them to solve log equations, right? The way that we're going to look at solving log equations today is to switch it to an exponential, right? We're going to use inverse operations. So the first step to solving these is to get the log by itself. So you want to get down to one log on one side, right? Then to solve it, we're going to switch it to an exponential. And by switching it to an exponential, we're going to be able to do some mental math or type it in the calculator, but we're going to be able to get rid of the log so that we can actually solve for the variable. All right, one thing to keep in mind, you cannot have a negative inside the log equation, all right? So inside the log, it does not work. If you end up with a negative inside, that means you have no solution. Now, your number itself, when you get down to x equals, that can be a negative number. But when you plug it back in, it cannot. Okay, so keep that in mind. You gotta look for those end up being no solution problems. All right, so for the first one, we got negative 10 plus log base 3 of n plus 3 equals negative 10. So the first thing I'm going to do is get rid of this plus 10 because my job is to get this logarithm by itself. Now, this is log of n plus 3. I can't separate that. The only way to separate these is switch to exponential, which we'll do later. But this is a value that I cannot break up, right? But I want to get it by itself, so I'm going to add 10 to both sides. So I get log base 3 of n plus 3 equals 0. Now we're going to switch to an exponential. So to switch to an exponential, we start at the base, we go around the world, and we come back. So I end up with 3 to the 0 power equals everything inside here, n plus 3. Well, 3 to the 0 power, anything to the 0 power, is 1. So I get 1 equals n plus 3. Then I can solve very quickly for n. I can subtract 3 from both sides, and we get n equals a negative 2. Okay, this can be negative, but when I plug it back in, it cannot. So negative 2 plus 3 is a positive 1, so we're good. Just can't have a negative inside the logarithm. Okay, for number 2, we got log of negative m plus 2 equals 4. Okay, now this is not a negative number, it's a negative variable. That's okay as long as when I plug in my number that I get for my solution, I get rid of all the negatives in there, right? So it's okay. But that log of negative m is what I want to get by itself. So I'm going to start by subtracting 2. So I get log of negative m equals 2. And then I'm going to switch to an exponential. Now this one looks weird because I don't have anything down there. But remember, the base, if there's nothing written there, it's our common log of base 10. So I'm going to start at my base 10, go around the world, and come back. Right? So then I have 10 to the second power equals everything inside, which is just negative m. Right? Well, 10 squared is 100. Okay, get rid of the negative by dividing by negative 1. So we get negative 100 equals m. Plug it back in, double check. So if I plug it in, negative 100 is really a positive 100. So we're set. Okay, and then for number 3, same idea, but now I have natural log. Remember, natural log is just like a log. It's a type of logarithm. It's just that it only goes with e. So keep that in mind. Plus, this one's also a little different because I have 2 natural logs over there. And how on earth am I supposed to get one natural log by itself, right, if I have 2? First, we got to combine them. So this is where our properties come in. I have a natural log minus a natural log. So with subtraction comes division. All right? So I'm going to take natural log of the first stuff divided by the second stuff. So we got this big old fraction in there. Okay, now I got down to one logarithm, one natural log by itself. So I'm going to start at the base. Remember, the base is going to be e, always. Go around the world, come back. Right, so I've got e to the 5th power equals 4x plus 1 over 3. Don't plug this in yet. It is a number. Remember, e is like pi. So that is a number that we'll eventually type into the calculator, but don't do it yet because then you got to deal with that long decimal finishing out the problem. So leave it just like that. And to solve for x, the first thing I'm going to do is get rid of that 3. So I'm going to multiply by 3. So we get 3e to the 5th equals 4x plus 1. And then subtract 1 from both sides. So I get 3e to the 5th minus 1 equals 4x. And then just divide both sides by 4. So one option, if it's asking you for an exact value, that means no decimals, I would leave it just like this. 3e to the 5th minus 1 over 4. That is perfectly fine. Or if it wants a decimal, you can type it into the calculator. And again, your phone calculator should have this on it. If not, you can easily type that into a calculator online. So on a regular calculator, a TI calculator, right, to get to the E button, I just use a division sign right above the divide. So we'll go second divide to get to E, right? And then, forgot. Got a, 3 in there. So I got 3. Then I'm going to go to E and raise E to the 5th power minus 1. And then I'm going to take that and divide by 4. So then my answer as a decimal will be 111, and it usually asks you to round to the 10th place. That's 1 decimal place. So here I have 0.5. 5 makes that go up. So I have 111.1 for x. All right, and you could double check. I can think about plugging that back in. I have all positives, so that's going to stay positive. I don't have to worry about it. All right, so there's solving our log equations.